Hello ladies and gentlemen, today our notes is 6.1, distance formula and midpoint formula. We're going to learn how to find the distance between 2 points on a coordinate plane. Two ways we're going to do that. One, with the distance formula. It's a special formula that will do it for you. It derives from the Pythagorean theorem, that's where it comes from. Another way is creating right triangles in a coordinate plane. And using the Pythagorean theorem. So we'll go over that along with the midpoint formula, which helps us find the middle point between 2 points on a coordinate plane. First, let's go over some definitions that you're going to need to know. As usual, like the title, please rewind and pause as long as you need in order to write things down. Here are some definitions you need to know, because you always get quizzed and tested on definitions. First, a circle, it's a set of all points that are equidistant from a fixed point. Right? So a circle is essentially an infinite amount of points that are all the same distance away from one point in the middle, which we call the center. Which brings us to the second vocab term. The center is a fixed point in the middle of the circle. That should be a pretty easy one. And then the radius. The radius is, if I have a circle, the radius is the distance between the center and any point on the circle. So this segment right here connects a point on the circle to the center. We call that the radius of the circle. Formulas, extremely important. Pause, rewind, get these written down. They should be pretty big in your notes. You should highlight them, box them, they are important. So first we have the distance formula. D stands for distance, is equal to, and then we have a large square root. And then you can see we have what we call x sub 2 and x sub 1. That just means second x coordinate and first x coordinate. And then we have same thing, y sub 2 and y sub 1. So that just simply means the second and first y coordinate, because you're using 2 points to calculate the distance between those 2 points. So you're going to have 2 x's and 2 y's. And simply you're going to subtract them, square them, add them together, and take the square root, and that will give you the distance between the 2 points. We will practice this, of course. We have Pythagorean theorem, which you should know about. Pythagorean theorem says that if we have a right triangle, that the legs A and B, and then the hypotenuse C. So if we square the legs and add them together, it will always be equal to the hypotenuse squared, which is C. And that is true for any right triangle. And then we have the midpoint formula, which is to find the middle point between 2 points on a coordinate plane. Pretty easy to calculate. It's simply the average of the x coordinates. So if I were to take the average of the x coordinates, I would add them together and divide by 2. And the same thing with our y coordinates. We're adding those together and we're dividing by 2. And we will go through examples that show the midpoint formula. Pause and rewind as needed. So let's practice a couple here, calculating the distance. So I will show you. These examples need to go in your notes, of course. So I'm going to show you the first way. So first question, find the distance between 2 points, A and B. A is -6,5 and B is 3, -2. So I'm going to show you how to use that distance formula that you already wrote down. But first I want to show you another way to calculate the distance between 2 points. Very similar to the distance formula. In fact, you can think of them as almost cousins of one another, because the distance formula actually comes from the Pythagorean theorem, which we will use right now. So let's say I'm asking you to find the distance between these 2 points. Again, they should already be written down. Pause and rewind as needed. Let's take a look at this graph. Pause and make sure that this graph is sketched into your notes and that you are practicing this. Everything you see on the screen needs to go in your notes. So pause and rewind as needed. So you can see I have point A, -6,5, and point B, 3, -2. And we're finding the distance between these 2 points, so I conveniently connected these points with a straight line. So we're finding the distance of this straight line. So we can do this by creating a right triangle in the coordinate plane. Can you guys pause for a second and see if you can pause the video and see if you can think, how can you create a right triangle in this graph? So I'm hoping that you guys envisioned it one of two ways. You can do it this way. So I can go from this point straight up until it's exactly vertically even with point A, and then completely horizontally even A and B as well. So I'm going basically straight up and straight to the left to essentially connect the points. And what that does is it creates a right triangle in the coordinate plane. And what's cool about that is now I can just use the Pythagorean theorem to calculate the distance, because now the distance between points A and B is the hypotenuse of the right triangle, right? Which is our C, right? A and B are our legs, right? So A and B are the legs of the right triangle, and C is the hypotenuse, which is also the distance between the 2 points. Can you guys tell me what is the length of leg A? And what is the length of leg B? Pause for a second. Think about that and answer the question. So I'm hoping you said that leg A was exactly, so if I start at A, I go what? 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So leg A is 9 units. I can label that 9. And leg B is 1, 2, 3, 4, 5, 6, 7 units. So I can label that 7 units. So we know the two legs of the right triangle. Therefore, I can calculate the hypotenuse using the Pythagorean theorem, which is a squared plus b squared equals c squared. It's a much easier formula to remember than the distance formula, right? That's why many people like this way better. 9 squared plus 7 squared equals c squared, which is the hypotenuse. It doesn't matter which leg is plugged in for A or B, because you're squaring them and adding them together anyways. 9 squared is 81, 7 squared is 49. You guys should have a calculator out. If we add those together, we should get 130 equals c squared. And then to solve for c, we want to undo the square. So some number squared is 130. To figure this out, we do the opposite, which is the square root. So if I square root, that cancels the square, and it tells me that c is the square root of 130. Punch square root of 130 into your calculator, and please tell me what you get. Pause the video. We should be getting 11.4, and usually we round to the tenths place, so we can say approximately 11.4. And that is the distance between points A and B on the coordinate plane, because that's the hypotenuse of our right triangle. So that's one way to calculate. Second way is to simply use the distance formula. It is harder to remember though. So that's why some people don't typically like to calculate this way. But let's do it that way as well. Make sure this goes on your paper. So the distance is the square root of, if I take both x's and subtract them and square them, take both y coordinates, subtract them and square them, and then I'm going to add them together. And then after I do all that, I'm going to take the square root of that value, and you're going to see we're going to get the same thing. So the distance is, let's plug in our 2x, right? Our 2x coordinates are -6 and +3. So I'm going to say -6 minus 3 squared plus, we're going to do the same thing with the y values. So we have to do the y values in the same order. So since I put -6 first in the order for the x's, I got to do the same order for the y's. So I have to say 5 minus -2. So 5 and then minus -2 squared. So let's clean this up a little bit and calculate it. No big deal. So -6 minus 3 is -9. And then I'm going to have to square that. And then 5 minus -2 is really just 5 plus 2, which is 7. And then we have what? -9 squared is 81. 7 squared is 49. Is this starting to look familiar? See? If I add them together, I get the square root of 130, which we already know is approximately 11.4. So that is calculating the distance using the distance formula, and also using right triangles. Two different methods. Think of them as cousins of one another. They're related, Just maybe two slightly different ways of thinking about it, but accomplishing the same thing, which is finding the distance between 2 points on a coordinate plane. And you can do that with any 2 points. Our second question, which you should have written down, pause if you need to write it down, is to find the midpoint of segment AB, which we already drew in the coordinate plane. So we need to find the middle point of AB. So if I'm going to use the highlighter, it's probably like somewhere in here somewhere, right? It seems like. So we're not going to guess, we're going to exactly calculate it. What are our 2x coordinates? You should be responding with -6 and +3. So if I asked you, what is the middle of -6 and +3? This is the x-axis. So say -6 is right here and +3 is right here. What is the middle coordinate, right? So we have what? 2, we got 1, we got 0, we got -1, we got -2, then -3, and -4, and -5. I know they're not evenly spaced out. But what's the middle coordinate? Okay, I'm hoping you're saying it's going to be right in the middle of it. So if I add those together, -6 and 3, it's going to be -1.5, right? Should be right there exactly. Make sure that one way. 1, 2, 3. Yep. So 1, 2, 3, 4, 4.5 away from 3. 1, 2, 3, 4, 4.5 away from -6. -1.5. Or what we did is we found the middle, we found the average. So what we do is we take what? The x coordinates and we add them together and divide by 2. When I do that, I get -3 divided by 2, which is -1.5. That's where the formula comes from. And the same works for the y-axis, right? The y-axis, see how it's at -2 is our y coordinate, 5 is our other y coordinate. So the middle is going to be like somewhere in here, right? We're not going to guess. We're simply going to take the y coordinates, which are -2 and 5. We're going to add them together and divide by 2. So here's how it looks on your paper. So we're just going to write midpoint and just write out the formula. So the midpoint equals, if I take the 2 x coordinates and I add them together and divide by 2, and I also take the 2 y coordinates and I add them together and divide by 2. My 2 x coordinates, like we already said, are -6 and +3. We're going to add them together and divide by 2. And then we're going to do it in the same order for the y coordinates. So -6 plus 3, so that means that 5 needs to come first as well here. So 5, add -2. But it technically doesn't really matter because we're adding. So the order technically doesn't matter when we're calculating midpoint. It's nice to get in that habit because then you get confused with other things such as slope or distance formula or things like that. So let's calculate this. -6 plus 3, we already did that. That was -3, so that gives me -3 over 2. And then 5 add -2 is +3 over 2. So, and you can leave them as fractions, and that would be fine. But if you did divide, you would get just the decimal equivalent, which is -1.5 and +1.5. And that is the midpoint of our 2 points. And you can see, let's go actually see where that is. So -1.5, +1.5. So let's see, -1, -1.5 is right here. And then if I go up 1 and then 1.5, look at that. It's right perfect right there. All right, that's the midpoint, -1.5, +1.5. And that's how you calculate it. So there you go, guys. That's your video regarding finding distance formula 2 different ways to find the distance between 2 points, and then also finding the midpoint. You have one more thing left to do on your notes, which is to write a summary. Please skip a line. And your summary is going to be, you need to explain exactly how you can find the distance between 2 points on a coordinate plane using right triangles. Explain that in words, please. That'll be the end of your summary and the end of your notes.